Good afternoon, everyone. Thank you for joining us on this World GIS Day 2025 for our webinar on integrating drone data into your GIS workflow. We are super excited to share two of our favorite topics, two of our team's favorite topics with y'all this week, those being GIS workflows and drone data. Um, We're going to start with a brief introduction of our panelists for today, and then we will get started with the information. First off, I am Matthew Berry, team for just over 3 years now. My background is in geography and remote sensing, so everything from satellites down to drones and terrestrial scanning as well. I graduated from Louisiana State University, where I developed a passion for drones while I was working on mapping projects there. And I proceeded to get my Part 107 license and have been a drone professional and mapping professional for over 6 years now. I'm an avid member of ASPRS, the American Society of Photogrammetry and Remote Sensing, and I'm looking forward to delving into some of my favorite subjects with y'all.
Hi, everyone. My name is Darian, and I am the GIS Analyst here at FlyGuys. I spend most of my time processing and analyzing LiDAR and photogrammetry data to create the geospatial deliverables our clients rely on. I've been a part of the FlyGuys team for about a year and a half now, and it's been really enjoyable bringing my academic and professional experience into a different side of the industry. And so I'm looking forward to walking through today's topics with you all.
So now we'll briefly go over some of what will be covered in the webinar today. We have it split out into four different sections. First, we're going to go over why data quality defines GIS intelligence. This is going to give you some background of what GIS is and why the source data quality is important, how that lays the foundation for all the other deliverables that you will ultimately use it to create. Then we're going to go into how to integrate your drone data for better outcomes. Sort of the history of aerial imaging and GIS cooperation, as well as going into why the drone data is important, how that drone data differs from some of the other data sources you typically see in GIS workflows. After that, we'll go over some best practices for data management and quality control, how best to store and manage everything, as well as quality checking. And lastly, we'll cover what's next, some of the future, and what is in store for smart GIS and the future of GIS data. First, a little bit about FlyGuys. FlyGuys is a leading marketplace for reality data capture, connecting businesses with a trusted nationwide network of skilled drone pilots and data professionals. With our advanced systems, extensive resources, and strict safety standards, we deliver precise, timely data for projects across all industries.
So to begin, let's talk about what GIS really is. While the field itself can be very complex, the fundamentals are pretty straightforward. GIS stands for Geographic Information System. It's a system that allows you to organize, analyze, and visualize data that has location tied to it. By bringing different types of spatial data into one environment, GIS helps you understand how things relate to each other and supports better, more informed decision making. But there is one key point. GIS is completely dependent on the quality of data that you put into it. If the source data is outdated or inaccurate, the output will reflect that. Poor data leads to inaccurate insights, and inaccurate insights generally lead to wasted resources. When the data is reliable, your GIS becomes a much more powerful, much more trustworthy, and much more useful tool. From GIS to smart GIS, modern GIS is really about making the work easier to manage and faster to act on. A helpful way to think about it is like a smartwatch. It doesn't change what you do, it just organizes information, handles tasks in the background, and surfaces insights that you might not notice on your own. SmartGIS does the same for geospatial information. It takes your data, like point clouds, imagery, and survey points, and uses tools like automation or AI to generate meaningful outputs more efficiently. A few examples that I want to include are things like catching bad data or inconsistent data upfront, automatically cleaning up your point clouds or classifying those points, running data through a more streamlined and continuous process, or producing clean, organized outputs that are simply ready to use. SmartGIS isn't about replacing the expertise, it relies on it. It's a system.
So now we've given a little bit of background into GIS and the smart GIS workflows that are becoming more and more prevalent in the industry in this day. We're going to go a little bit into why drone data matters. As many of y'all are aware, GIS does not specifically relate to drone data. It is about all geospatial data, and it is about mapping and pulling insights out of that geospatial data. But drone data is becoming more and more prevalent in GIS systems and GIS workflows because of some of the advantages it has over the different data resources and options. So going back all the way back to the 1850s, aerial imagery really isn't a new thing. People have been going up in hot air balloons and taking aerial imagery that did not have location-specific data and was not high resolution at all, and using that to draw insights from the geography around them. That has been replaced by many different systems over the years, moving from hot air balloon to manned aircraft when those are available, and then ultimately to satellite. Another big revolution was the addition of GPS data in the early 90s. This allowed, in 80s and 90s, this allowed for high accuracy location specific data to be collected a lot more easily and to be able to provide greater insights between all of that. Drones are really the culmination of all of these factors coming together, providing high resolution, up to date, and location specific data. Previously, you had to choose between one or multiple of these and the other options that you were using. It replaces the outdated satellite imagery by obtaining much more high resolution. So previously, you could get up to date and location specific data from satellite imagery very easily, and pretty much any day of the year. You could take imagery from any section of the world. Unfortunately, it was limited to a certain resolution because the cameras are in outer space and the satellites. Drones have brought everything back down to the surface, allowing us to take very high resolution imagery in the same up-to-date and location-specific manners. Another big advantage is another big leap in drone data is that 3D and digital twin modeling have become increasingly prevalent in drone data, and there are many systems that allow for you to be able to create these deliverables with very little experience in CAD analysis or modeling previously, and zero experience in photogrammetry previously. These were all things that were required in order to process these deliverables before drone data started becoming more prevalent. As well, it strengthens the GIS accuracy and speeds up the decision making. This is due to those real-time, real-world analysis that are able to be made. You can go to not having to worry too much about cloud cover, not having to worry too much about airspace. Drones allow you to get in to an area, collect accurate, high-resolution data any day of the week, as long as it is not actively storming. As well, the verified timestamps and metadata that are being written into the imagery as the drone is collecting the imagery ensure for much more trustworthy results than the imagery that was previously used when incorporating into your GIS workflows. Unfortunately, there are a couple of drawbacks that come with these added bonuses. Some of those are with the high resolution and the high accuracy. There's a lot more data that is to be worked with. And so that is one of the drawbacks that comes with drone data is that you are dealing with very large data sets with lots of metadata at times. So how do we work around this and how do we integrate the drone data into our GIS workflow in order to avoid some of these challenges? And what are these specific challenges? So as some of you may know, and as many of the GIS professionals are aware, different file formats and size limits have always been an issue with the softwares in the GIS profession. Certain softwares only allow certain formats and file sizes. AutoCAD is a good example of this, as it is very limited on the size and the format that can be imported into it. Whereas systems like ArcGIS are a little bit more democratized in allowing the format and size limits to be able to be imported into them. As well, another challenge with specifically drone data into a GIS workflow is the large data sets I just covered. The large data sets and storage management can create issues when integrating your drone data into GIS, as many times the large data sets of photos have to be stitched into a single site image in order to be used and pull those insights out of it. By merging those, by managing those large storage sets, you can get confused on where things are and how things are supposed to be maintained, which can ultimately provide bad source data and bad insights, as Darian was referring to earlier. So some of the solutions that we have found for this is choosing the right software for each data set and deliverable. There are many different softwares out there. There are many different use cases for each of those softwares. Find the right software that suits your needs, become familiar with it, and know its limitations. Know what it can and can't do. There may be a point in time where you have to go to a different software and learn that other software and expand your uh, repertoire of softwares. But for beginning, just find the one that fits your needs the best, use that one, and then go from there. As well, maintaining consistent formatting and metadata will help with managing these large data sets, as well as in knowing which formats and file types work with which softwares. So we'll go a little bit more into the actual management of large data sets shortly, but just being able to have a consistent standardized workflow to be able to bring the data in and use it in an efficient manner in order to import into your GIS systems and pull those insights and data that you need out of it in order to improve your overall quality. Lastly, the solution that we use in-house is we have a quality control team here at FlyGuys that reviews every job and every data set that comes through. This allows us to be able to ensure the overall deliverable accuracy and the timeliness to our clients. Partnering with solution formats similar to FlyGuys or other platforms is one way to ensure that you can maintain high quality control.
So, data accuracy and quality control play a huge role in how smoothly a GIS project runs. And from our experience, many of the challenges that show up can often be traced back to the source data. Some of the common things that we run into are outdated imagery or missing features, inaccurate client provided data or areas of interest, or even elevational inconsistencies that require some reworking. Small issues like these can snowball pretty fast. They slow down the workflow and can add uncertainty to the final deliverables. And once you start fixing one thing, it often can reveal another issue further down the line. So a few ways to reduce those setbacks can look like verifying your timestamps, clarity of the data and completeness of the data, communicating early on with your clients and making sure that the clarity is all across the board, and maintaining consistent file organization and QC standards. These steps may seem simple, but they make a noticeable difference in how predictable and clean the final GIS product turns out. And that kind of goes hand in hand with best practices for data integrity. Once the data is captured, the next big factor in keeping a project on track is how that data is managed as it moves through the workflow. Consistency, structure, and clear communication are essential. They help ensure the work is done right the first time and delivered on schedule. Like Matthew said, metadata is also a big part of maintaining data integrity. It's essentially the information that explains your data, so data about your data, and it explains things like capture date, equipment use, coordinate systems, and more. Keeping the metadata intact throughout the process helps maintain traceability and gives end users the confidence in the accuracy and reliability of the data that they're receiving. Another best practice is try not to rush any type of automation. While yes, automation is incredibly helpful, it only performs well when the underlying data is solid. So if the foundation isn't clear or structured, automation will just amplify the issue. And finally, as we've kind of mentioned before, partnering with trusted platforms and providers makes a huge difference. That's one of the biggest strengths that we have here at FlyGuys because so much of the data is captured in-house. We already know the quality, the equipment, and the workflow behind it. That built-in reliability gives us and our clients a higher level of confidence from the start.
So what is the future of GIS and what exactly, how is smart GIS leading us there? So the future of GIS is improved accuracy and real-time integration, being able to integrate these real-time uh, reality data metrics into a 3D digital twin model is where everything is leading at the moment. The Dallas Fort Worth Airport is a great example of this. The Dallas Airport that feeds in information from various systems within their ecosystem, such as their water pressure, their fire systems, and their TSA wait lines. These allow them to draw crucial insights that into making decisions for how they're going to operate. It allows them to improve the experience for their customers that are using their facilities, as well as optimize the efficiencies in their own processes and lower their manpower while needing to monitor these processes. These sort of solutions are the future. They will, the digital data, the ability for digital data to improve the collaboration between GIS users is the sky. The sky's the limit. Uh, it will allow multiple users from worlds away to collaborate all on the same uh, data sets and be able to pull insights out of them for their needs as well as their users. Gone are the days of 2D maps. Everything will live in multi-layered digital twin ecosystems where the digital data is able to be equally shared and be able to create a working real-time model of the entire world. And that is the future of smart GIS.
So some key takeaways, and to wrap things up here, these are a few main points to leave with. Data quality defines GIS intelligence. The smarter your data, the smarter your insights. Drone collection gives you accuracy, consistency, and verifiability, which makes your GIS output far more reliable. Smart GIS turns data into insights, reducing manual effort and improving decision making. And integration, consistency, and strong metadata practices are essential for building trust in your data. If you want to dive any deeper into today's topic, you can visit our FlyGuys blog and check out the article titled "Your GIS is only as smart as your data source." We will also be sharing this recording for the webinar along with some contact resources at the end. And thank you everyone who joined for today. I think we will be moving into some question and answers next.
All right, so one question we have is once the data reaches GIS, what tools do you rely on for an initial QC check?
Yeah, so I can go ahead and answer that. First and foremost, we check that all the source data we need is actually there. If it's, for example, a LiDAR project, we often use the software DJI Terra during processing to generate the initial point cloud, and that lets us confirm things like RTK connectivity and full coverage of the flight. Once we bring that data into our processing software, we do a quick quality check against, the KML boundary or the area of interest, just to make sure that all of the site is included and matches what the client is requesting. We'll also open any CSV files that contain GCP points, check shots, survey points to confirm that the datums align with the project. That combination is what we consider our initial QC before any detailed processing begins.
All right, and when do you choose photogrammetry versus LiDAR?
It's a really good question too. So photogrammetry is great for things like 2D maps, visuals, or general terrain observations. It works by using a statistical algorithm to recreate the scenes from overlapping photos, whereas LiDAR is best for if the area has dense vegetation, accuracy requirements that are specific, or if you need any type of real precision and elevational modeling. It's able to judge the actual distance that the lasers travel, giving you true elevational measurements. And so I would say if the project needs any type of elevation, if there's heavy vegetation on site, it needs to penetrate canopies, LiDAR is the way to go.
Okay, is drone data always the best remote sensing option to use?
I can take that one. So as we went into, drone data has its benefits, of course, but drone data is not always the best. I would say it is a case by case basis. Even we at FlyGuys do not always use drone data. We will use the best reality data capture method available to us, which sometimes includes, manned aircraft, satellite, or terrestrial scanning, as I was saying earlier. Um, so when to use it and when not to use it. Drone data, as I was saying earlier, is really great for high resolution imagery, but can sometimes give you very large data sets. If you do not need the insights that the high resolution imagery entails, or if you are covering a larger area, and you still need those level of insights, I would suggest using, manned aircraft or something with a low resolution. Satellite is very limited in its resolution still, with only about a meter or so, and some of its higher resolution areas. Um, so just being mindful of that, of what is the resolution that you need, what is the area that you're trying to capture, and fitting those in with the best remote sensing technique.
Okay, what is the biggest issue that the team encounters with data storage?
Yeah, I can go on to that a little bit as well. Um, Data storage, our biggest issue that we face is archiving, keeping that long storage of data. So, we bring in a large data set, we process it, we make even more data out of it when we're processing it. And now where are we storing that data in the long term so that, we can cover ourselves, cover our clients, be able to readdress it if needed. Um, Having an archive or a server for that long-term storage is one way to address that issue. As well, just having large storage drives and NVMe drives, preferably on your internal processing desktop, um, that will allow you to deal with those, as well as using your partners and your resources. There are partners out there that do automated processing that allow you to upload to their platforms, allow you to store in their platforms. So if you do not have the processes, the capabilities to be able to store the data or process the data yourself, make sure that you are using those partners and resources effectively.
Okay, and what is the best way to store a drone-derived base map for others to use or to use within an organization?
I'll follow up on that one as well. Um, so the best way to store it for someone to use or someone to use as an organization, if you're wanting to collaborate with other people, would be to store it internally, but then produce a ArcGIS online map with the data. Um, if you take that data and you put it into an ArcGIS online map with that base map in there, then anyone who has access to that ArcGIS online map would be able to do this. Fortunately, you would have to require access to ArcGIS, that is a paid software. If you're just looking for storage capabilities, though, as I said, the NVMe drives are really great for storing large sets of data. Um, so I think that kind of answers that question. Darian, did you have anything to add there?
I would agree. I was going to mention the ArcGIS Online as well. It's a really great platform for sharing and being able to collaborate with the data pretty easily.
So what resources do you recommend for additional information about GIS and drones?
That is a great one as well. So kind of following up on that, the last one talking about ArcGIS, their parent company, Esri, ESRI, is a great resource for all things geospatial. They are the the blue ribbon when it comes to geospatial softwares, in my opinion. They offer many trainings and user. There are a great resource, a great amount of resources in other areas. Also, NOAA has a lot of resources as well, and other companies that we like to use for our resources are some of the partner companies we have that deal with processing, those primarily being Drone Deploy and Propeller. We like to go to our partner and use their knowledge bases, use their resources in order to learn more. As well, we are always available here at FlyGuys. We are a resource. Um, Feel free to reach out to us. As Darian said, there are our contacts should be in the next slide. So always feel free to reach out to us and pick our mind. We love talking about this kind of stuff.
And just to include, if it's just, information or, improvement of knowledge that you might be interested in, looking for resources that way, it is a very simple tool and we all use it all the time in our everyday lives. But honestly, YouTube is really beneficial. There are a lot of pilots out there and GIS experts that have channels or will go in and just kind of have a really good explanation of some of the things you might be looking for.
Perfect. We're going to take just a couple more questions, and then, as Matt and Darian said, the next slide will be their contact information. So we encourage you to screenshot that contact information and follow up with them. If your question did not get answered, we'll also try to reach out proactively as well for questions in the chat that did not get answered and answer those post-webinar. So just a couple more questions here. What will be a critical example of wrong data? What would your suggestion be for drone operators?
So, a critical example of wrong data, in my opinion, and this is, probably our most common example in LiDAR, not exactly in, it happens in photogrammetry a good bit as well, but it's just missing data. A lot of times we'll get data sets in that while you're capturing, it looks like it's capturing everything appropriately. And then you get into the back end and you're either missing images or missing, parts of your point cloud, your LiDAR point cloud. Um, the best resolution to either of those are things you probably don't want to hear, but that's going to be to go out and recapture those. That's why doing that QC in a timely manner is very important. We do that initial QC, or we try to do that initial QC before all of our pilots even get off the site. So we are processing through Terra, we are inspecting it, we're making sure that everything got processed appropriately and that everything is captured in there before we even pull our pilot off the site. That way, if there is anything that's missing, if there is anything that needs to be recaptured, they can very quickly do it while they are still on site. I know that is not always available for everybody if you're traveling long distances or things, but that is a best practice in my opinion. Uh, Darian, did you have any other examples besides just missing data?
Um, no, I really do agree with the missing data as being one of the most critical. I guess maybe a little less critical, but still pretty important is, always making sure that what you're taking it in, whether it's meters, US survey feet, it all aligns with your data across the board. Because while it's not necessarily an impossible thing to fix or there's a solution for, it's not always the easiest, and sometimes it's a little difficult to backtrack and can cause some alignment issues on the back end.
Yeah. And I'll just follow that up as well. Um, Aside from the drone data itself, another big part of the GIS data and making drone data good for GIS use is having that georeference to it, having that reference to it. And so knowing that your georeference data is good, knowing that whatever RTK system that you're connecting to is trustworthy, knowing that whatever controls that you set out are correct, knowing that the datums and the coordinate systems that you're collecting those controls in or that you're collecting that data in is also correct as well. There are things that can be done to manipulate the data on the back end in order to ensure that it is correct, but those are the most widely seen things that we encounter. And checking your controls can be as easy as pulling up a topo of that area, looking at what the expected elevations would be, going to your control survey, looking at your elevations and saying, yes, this is about what it should be. Making sure that you're not supposed to be looking for 160 feet and you're at 200 something feet. Um, those sort of things are critical, in my opinion, and the easiest things to catch.
Yes, absolutely.
All right, and this will be the last question for today. Are the data processing workflows similar for integrating multiple remote sensing data sources such as terrestrial scanning and drone data?
That is a great question. Um, a lot of that depends on the system that you're collecting with. Integrating them into your ultimate GIS workflow is similar, but your terrestrial system may not work as closely with your aerial system off the bat, if the best way to put it. So you may have to process some of that aerial and terrestrial data separately and combine them once you get into your deliverables or post-process workflow. Um, but if it's just combining the deliverables, if you're trying to combine data sets, like I said, that depends a little bit on the sensor, especially in a LiDAR capability of how the sensors operate together. Um, but ultimately, it is, essentially the same workflow whenever you're putting it into that GIS system. You are pulling the deliverables, pulling the insights, pulling the information, the data out of each of those point clouds, out of each of those systems, and putting them into your GIS system in order to be combined. And you can evaluate both of those measurable insights effectively in both cases at the same time.
Perfect. Darian, do you have anything to add?
No, I don't. I agree with everything Matthew said, and I think that was a really good way of explaining it.
Perfect. Let's go ahead and go to the next slide with contact information.
Awesome.
All right. Well, thank you everyone so much for joining us today. We hoped you learned a lot. We have a lot of questions in the chat. We're not able to get to them all today. However, we will reach out to answer these questions, and you also can screenshot this contact information and follow up with Matthew and Darian. They're both experts. They're both great resources, and we're happy to help and answer any questions you may have.
Yeah. Thank you everybody for coming today, and appreciate it. Just reiterating what Stacy says. We love being resources, especially for our pilots and our pilot network or our clients that our SAEs have brought in. So please use us as a resource. Our phone numbers and emails are below. As well, if you have any issues getting in touch with us, please reach out to other team members and they can reach us as well. But we look forward to talking more with all of y'all, and thank you for coming to our webinar today.
Yes, thank everyone so much.